Welcome back to the deep dive. Today, we are wrestling with a topic that often feels like this tangle of wires and acronyms. We're talking about AWS networking.
Yes, true. Networking can be an instant headache for a lot of people, but it's also the absolute foundation of your cloud security.
Right.
If you joined us last time, we talked about building your house, your EC2 instances. Well, this deep dive is all about the fence around the property and, the security guards at the gate.
Creating your own private fortress inside the public cloud.
Exactly.
So that's our mission today, understanding how to build and manage those secure boundaries. And our sources all point to one place to start, the single most important concept in AWS networking, the VPC.
The Amazon Virtual Private Cloud.
Okay.
Right. So think of the entire AWS cloud as this massive, bustling city. It's public, shared by millions.
Okay.
Your VPC is your own private, gated community that you build right inside that city. It's logically isolated, and by default, it is completely sealed.
Sealed. So nothing in, nothing out.
Nothing. If you don't build a gate, nothing happens. The isolation is total.
Okay, so I've claimed my little plot of digital land, but a fortress is useless if it can't, connect to the world. So we need gates.
We need gates.
Yeah.
And you don't just get one standard type of gate. You get different kinds for different jobs.
So it depends on what you're trying to do.
Entirely. If you're running, say, a public website, you're going to need an internet gateway. An IGW. IGW. Got it. That's your main front gate. It's wide open to the public road, the internet, and it handles all your public traffic.
Makes sense. But we work with clients, banks, healthcare. They use AWS, but they absolutely cannot have their data touching the public internet.
And for them, you'd never use an IGW. For that, you use something called a Virtual Private Gateway, or a VGW. You pair it with a VPN.
So this is like a private tunnel.
Think of it as a secure private backdoor. It connects your VPC only to your on-premise data center. It just avoids that whole chaotic main street of the internet altogether.
And then there's the premium option, the one where you're literally laying down fiber.
Right, AWS Direct Connect. So the VGW and VPN, they still use the internet's roads. They're just in a sort of armored car.
Okay.
Direct Connect paves you your own private highway. It's a dedicated fiber optic line straight from your office to AWS. You avoid all the public traffic.
So if I were explaining this, I'd say IGW is the free public front door. VGW is a private back door using public roads. And Direct Connect is your own super expensive, super fast private highway.
That's a perfect summation. And adding that context, the cost, the regulation, that's what makes it a real architectural decision, not just a definition.
Okay, perimeter secured. We've got our gates. Now let's go inside the fence. A VPC is huge. How do we organize everything inside it?
We slice it up. You cut the VPC into smaller, more manageable zones called subnets.
Like neighborhoods inside the gated community?
Exactly. And this is where you hit the golden rule of cloud architecture. Public versus private.
Public versus private.
Your public subnets are the ones that are wired up to the internet gateway. That's where you put things that need to face the world, like your web servers.
Okay, and the private subnets.
They have absolutely no direct route to the internet gateway. They are sealed off from the public.
And that's all about security, right? You hide your crown jewels, your databases, your internal services in the private subnets so attackers can't even see them from the internet.
Precisely. It's all about defense in depth, creating layers. But this brings up a classic problem, one that trips up everybody when they're starting out.
Oh.
If your database is in a private subnet, totally sealed off, how does it get security patches from the internet? It needs to talk out to get updates, but we can't let anything unsolicited talk in.
That's a great question. You need a one-way door.
You need a one-way door, and that is the NAT gateway, Network Address Translation. This thing is so important.
Okay, so how does a NAT gateway work?
So you place the NAT gateway in your public subnet. Think of it like a secure mailroom.
A mailroom, I like that.
The database in the private subnet sends a request out, hey, I need this security patch. It sends it to the NAT gateway. The NAT gateway then goes out to the internet for it, gets the package, and brings it back.
And the key is that the internet only ever sees the mailroom's address, right? Never the database's private address.
You've got it. The internet can't initiate a conversation with the database. The NAT gateway makes it a one-way street, outbound only.
That's a crucial piece of the puzzle. Without it, your private subnets are so isolated you can't even maintain them.
Yep. So now we have the VPC, we have public and private subnets, and the NAT gateway bridging that gap.
So let's dig into the firewalls, the things that actually inspect the traffic. NACLs and security groups.
Right. And this is all about macro versus micro. And the one word you have to remember here is statefulness.
Statefulness. Okay, let's start macro. The Network Access Control List, or NACL, where does that live?
The NACL operates at the subnet level. It's the passport control officer standing at the border of the entire neighborhood. It checks every single car or packet that tries to enter or leave the whole subnet.
And its defining feature, the one that makes it a real double-edged sword, is that it's
It,
stateless?
it has no memory.
Zero.
So imagine your server sends a request out. The NACL says, okay, you can go.
Right.
When the answer comes back from the internet, the NACL sees it as a brand new, totally unrelated request trying to get in.
Oh, wow.
So you have to write a rule to let the request out and a totally separate rule to let the specific response come back in. If you forget that second rule, the answer just gets dropped.
That sounds powerful, but really easy to mess up.
It is. It's a very strict safety net. Now let's compare that to the security group, the SG.
Okay, so that's the micro-level firewall.
Exactly. The security group is a bouncer standing right at the door of your specific server, your EC2 instance. It only cares about traffic for that one machine.
And unlike the NACL, the security group is stateful.
It has a memory. It makes your life so much easier.
How so?
If the bouncer checks your ID and lets you into the club, the server, he remembers you. So when you leave, you just walk out.
So if you allow traffic in?
The return traffic is automatically allowed back out. The security group remembers the connection and just lets the conversation flow.
That is the single biggest difference, and probably the source of a lot of troubleshooting headaches. NACLs are stateless at the subnet border. Security groups are stateful at the instance store.
You've nailed it. Those two things are your entire internal traffic filtering system.
Okay, so we've built our fortress, we've organized the rooms, we've hired the guards. Let's zoom back out and talk about the global layer. How do people even find our front door in the first place? Let's talk about Route 53.
Route 53, it's AWS's domain name system, or DNS service.
Also known as the phone book of the internet.
That's the classic analogy, yep. It just translates human-friendly names like, www.ourshow.com into the IP addresses, the numbers that computers actually use to find servers.
And I have to ask the nerd question, why 53?
That's the little Easter egg for the network engineers. DNS traffic, by standard, operates on port 53.
I love that. But, calling it just a phone book really sells it short. It's more like a smartphone book or a smart GPS.
It's way more than a phone book. Because it's integrated with AWS's global network, it can make intelligent routing decisions.
Okay, like what?
Well, for starters, geolocation routing. Route 53 knows where your user is. So if someone from France visits your site, it won't send them to a server in California. It'll automatically route them to your server in Paris.
Send them to the closest one. That's intuitive. But closest isn't always fastest, is it? Sometimes network congestion makes a farther server quicker.
And that's where the real intelligence comes in. Latency routing.
Latency routing.
This sends users to the AWS region that provides the absolute fastest response time for them right now. So if for some reason the network path from Tokyo to London is faster than to a server in Singapore,
it sends them to London.
It sends them to London. It's all based on pure speed, which is critical for global apps where every millisecond counts.
And it's not just about speed, it's about being reliable too, right? What if a server goes down?
That's the other key piece, health checks. Route 53 can constantly ping your servers. If the one in Virginia suddenly stops responding,
it stops sending people there.
Instantly.
Yeah.
It'll automatically reroute all U.S. traffic to your backup site in, say, Ohio. It's what keeps global applications online.
That really ties it all together. So we have the VPC as the house, subnets as the rooms, security groups and NACLs as the different guards, and Route 53 as the smart GPS guiding people to the fastest, healthiest front door.
It's the whole framework. So let's maybe run through a few quick-fire scenarios just to lock it all in.
Pop quiz, I'm ready. Scenario 1. I have a server and a private subnet. It needs to download virus definitions every day, but I can't let anything from the internet connect to it. What do I use?
That is the textbook use case for a NAT gateway. You put the NAT gateway in your public subnet, and you route the private server's outbound traffic through it. One-way communication, perfectly secure.
Perfect. Scenario 2, the firewalls. My web server in a public subnet is trying to talk to my database in a private subnet. The request goes out, but the answer from the database gets dropped. The security group on the database looks fine. What's the likely problem?
If the stateful bouncer, the security group is fine, you have to check the stateless passport officer, the NACL.
The NACL.
You almost certainly have a rule allowing the traffic in to the database subnet, but you forgot to add a separate rule to allow the response traffic back out.
The memoryless guard strikes again. Okay, final one. My company is launching a global service with servers in Sydney, Frankfurt, and Virginia. I need every user, everywhere, to be sent to the region that is provably the fastest for them at that exact moment. Which Route 53 policy do I use?
That has to be latency routing. Geolocation gets you close, but only latency routing does the real-time speed test to find the absolute best performance for every single user.
You have officially tamed the tangle of wires. We've gone from a mess of acronyms to a clear architectural map.
Well, the goal is to put you in the driver's seat of your own cloud design. And that brings us to one final thought, something for you to chew on.
Okay?
We talked about NACLs being stateless and harder to manage, and security groups being stateful and more convenient.
Yeah.
So here's the question. If security groups are so great, why do we even bother with the old, clunky, stateless NACLs anymore?
I mean, we said it was about layers. The NACL is the neighborhood, the SG is the house.
It's about zero trust. The NACL is your absolute, unforgiving safety net. It forces you to be explicit about everything crossing that subnet boundary. So the real question is this. Since we know we all make mistakes, we all misconfigure things eventually, how essential is it to have that belt and suspenders security layer, that stateless firewall that guarantees nothing gets through unless you consciously, explicitly approve both sides of the conversation?
That's a great challenge. That layered defense as the ultimate insurance policy against our own mistakes.
Well, that wraps up our deep dive on AWS networking. Next time, we move from networks to people as we dive into Module 6, Security IAM and keeping the bad guys out.
Looking forward to it. We'll see you then.